just to see if it's everything set up. I'm watching now that it's me. That's kind of funny. The music. Just to see if it's everything set up. I'm watching now that it's me. That's kind of funny. The music. I just think that it's kind of low. The volume is kind of low. I don't really know that, but I'm not sure about it. But I will just increase a little bit the output gain and the attack. The volume, right? I don't really know that, but I'm not sure about it. But I will just increase a little bit the output gain and the attack. Right? Okay. Yeah, I think that this is good for now. Let me see. Yeah, I think that the attack can be decreased a little bit, like this. Let me see. Yeah, I think that the attack can be decreased a little bit, like this. Okay, I don't really care for it now. So I just want to see the chat. So I don't know how to do it in this YouTube thing. Let me see. I don't really care for it. Duration, activity. So I just want to see the chat. So I don't know how to timestamp, reactions, YouTube. I just want to detach this. It isn't possible. Maybe it's not. Let me see. That's my video. Why I can't have a place just to see the chat? I don't know why. I really don't know why. Well, it's okay for me. I don't really. This doesn't really bothers me. I can just enter in here, let the video. Yep. This doesn't bother me. I can just let the video in my corner here in my second monitor. Let the little teeny. Let the video. And okay, I think that works. This doesn't bother me. I can just let the video in my corner here in my second monitor. Let the little teeny. Let the video. Okay, let's go. A mode. Let me see the distribution primitives. Okay, I think that I will write one annotation file by subchapter. I don't know if I can say like that. I can say subchapter, but I'm just gonna do this, right? Yeah, okay, I'm not gonna do this. I will just write one for the entire chapter because I don't really write that much when I'm studying, so I don't care. Building a distributed system .md, and let's open it with him. Oh, cute. That's cute. Okay. Yeah, I don't have this to do HTTP server because this is the project that is built in the beginning of the book, and I just jumped to this chapter, and I am really I just don't want to he do everything again, so I will just begin from here. I will make a big reading of all of this, and I will try to apply that knowledge in some little project, or just in the terminal, or just in the EX. I don't know how I'm gonna do this, but yeah, I think that it's gonna be like that. Yeah, in this image we can see that we have a lot of clients, right? And we have a big cluster, and in each cluster we have nodes, and in each node we have the how can I say that, we have the group or backend. So we have the server and we have the database, so we can balance the load between these different nodes, right? If this one is full or is kind of low, the height is a mess, so we can just send the HTTP requests for this one and the same for the next one, and when everything is really loaded, we can just add another node, and the load balancer can just redirect the HTTP requests for this new one. Oh, the music is too sad. I don't want to listen to it. Neither that one. Why is play only Linkin Park? Okay. I really like that band. Just to listen to it. And next, okay. No, just keep going. Oops. Okay. This is really nice, because I know how to accomplish that with Nginx, for example, but I have no idea how to do it with Elixir and Erlang and the Bean stuff. Oh, that's really good. Hidden obvious. Bom dia. Oh, I'm sorry, I forgot. Good morning. Oh, in the RPC approach, we have a kind of internal network requests. So it's like a local call. In Elixir and Erlang, we don't have that. We can just distribute things between the nodes because they are all processes, right? So you can just send messages from one process to another. So it's more simple. It's simpler. Yep, in these terms, the live view itself is a distributed system. I mean, the HTTP requests, when you have a client and when you have a API that consumes, or when you have the client that consumes the API, you have a distributed system, right? Yeah.
Produto destinado a adultos.
Yeah, I don't have YouTube Premium. Oh, that's important. Every time you send a message to a process, this message is being copied from one process to another. So you have, if you think in a really big application that is doing that million times, I don't know, millions of times through a day, you will maybe have a problem with the load. Yeah, the problem is that it's kind of fire and forget, you know. You send a message to a process and you can't really know what is happening in that another process. So that can be problematic because it makes difficult to deal with the error or the warnings or the edge cases when you send a request, right? Right. Okay, the promise here is that in Erlang, and that means in Elixir too, distributed systems can be simplified because of the nature of Erlang processes communication. Let's see. Okay. Distribution primitives. Let's go. Hear your voice. A node is a bean system, bean instance that has a name associated with it. Okay, this is good. Primitives. I know how to write, okay? Is a bean instance that has a name associated with it. Okay. Node. Yeah, that's good. We can rely on the familiar message passing mechanism of Erlang / Elixir, and this is really good because we can deal with the error handling with supervisors, right? Or gen servers. To set up a cluster, you need to start a couple of nodes. Okay, a cluster is a group of nodes. Okay. Oh, that's cool, right? We can just do ex, let's see, ex, s name, and we can do the name for it. Let me see. Real fast. I hate ads. I'm sorry. So ex s name. Let me see the name. Hyper. Localhost. What's it? Okay. Localhost. Okay, just localhost. I can just do this. My window manager is broken. Provides the node name. Okay, the shell reports the name, the node name. Okay, so I have to cr. Okay, I have the node name. Using s name turns your bean instance into a node. Here? Oh, here. It's the unique identifier. Okay, that's the host machine. I really want to do this running a distributed system between my main machine and the other machine that I have here, that is just a Debian in a really low cost hardware. Part before. Okay, the second part identifies the host machine. Okay, so if I had did this, well, oh, okay, it had used it. Okay. Some problem here, but that's not my problem. Okay. Oh, that's why S name, it's short name. Oh, that's good. So we can provide a long name with a symbolic name or a IP address. That's good. Okay, nice. So I can know the name of the node. Yay. Yes. Okay, I have this one here, and I will just create another one. Okay, I can call it anything. Let me see. I'll call it tech, localhost 2. Okay. Okay, I have another node. That's my node name. Oh, I can connect with another node just like that. It's really simple. You want to connect it to another node. Okay, let me see. Node connect, and I can just provide the atom with the name of the node that I had created. That's really good. The name is Hypa. Okay, I'm connected, maybe. Solution nodes are considered to be connected, and all communication between them takes place via disconnection. Okay. All communication between them takes place. It's really good. You can prove that nodes are connected by calling node leaves. Okay, let me see. Okay, I'm connected with it, but what it had to show if I was not connected with any node. Okay, but I will run it here too. Node.list. Okay, techno. The techno is here. Okay. Yep, it's pretty much this that is happening. Oh, okay, good to know about it. If you start a third node, node 3 for example, and connected to node 2, a connection is established to all others node that node 2 is connected to. So it will end up creating a shared network between all the nodes. Good to know about it, because if I want to take one of these nodes to do something like a reverse proxy, I don't want that all nodes to be connected with this reverse proxy, right? So this is good to know. I don't want to create it. Mouse to establish a connection to a single node from the cluster. The new node will then automatically connect to all nodes. Okay. To get a list of our nodes cluster, including the current one, you can use, okay, this visible. Okay. Use node list, this visible. Okay. You want the current node to appear. The visible option indicates that you also want to get the list of all visible nodes. Oh, because if I do that, if I do this, I will only get the name of the node, that current node, you know. Visible, when I specify the visible atom, I'm telling the Elixir to show all nodes that are connected. Okay. It's possible to start a node hidden. Okay. Node disconnection deserves a special mention. After connection solution. Oh, this is good. Each node periodically sends tick messages to all of its connected peers to check whether they're still alive. Okay. Oh, this is good. There is an automatic attempt to reconnect the nodes when one of the nodes fails, but you can configure that when a node fails, you will send a notification and you can deal with this retrying logic. Using node monitor function, whatever. Let me see about it. Oh, what's going on? Elixir node monitor. Let's see. Monitor. Yes, you have it here. Yeah, it didn't specify the version. Maybe it's because of it. Yeah, I think that it's because of this. Yeah, that's, yeah. Yeah, but I can just send the atom that is the name of the node, right? Let me see. Node monitor, and I will send the I'm on the current node is hyper. I will send the techno one. No, I think that I have to send a flag. What is this flag about? Oh, a flag is true, monitoring is turned on. Okay, a flag is false, monitoring is turned. Okay, so I will just do true. Let me see if I will receive something when I shut down. Can't see any notification. Maybe I have to use some other function, right? Okay, but I'm connected already or not? No, I'm not, because I shut it down. So I have to connect techno. Oh, but that isn't the entire name. I forgot to put the localhost part. Localhost. Okay, now I'm connected, and I will set the monitor. Okay, true. So let's see. Still nothing. So okay, I just don't know how to do this properly now, but we will discover it. Let's list the nodes. We are all here. We are all connected. Okay, that's the beginning. For monitoring status changes of all nodes, see netkernel monitor nodes. Oh, you can monitoring all nodes. This is really interesting. Monitor node. Okay, I'm not gonna see this again. I'm not gonna see this now. Let's continue. Oh, okay. It's just what I had just see. What I have just see. Right? So, I'm sorry. I'll demonstrate how this works a bit later when I discuss network partitions. Okay. Node spawn, which receives a node name, and a lambda, the function is. Okay, I can spawn a function. Let's see. I'm connected, so node spawn. The first argument is the name. So I send it to hyper, right? Hyper localhost, yes, localhost, and now it accepts a anonymous function. Yeah, I will do this in the beginning. Hello. Just sent it. Let me see. Don't have nothing here. Let's continue. Okay, the output proves that the lambda has been executed in another node. I'm missing something here. I send it to hyper, right? I'm seeing the hello here. How can I see the hello in another node, like here? Maybe I have to use a receive to get the inbox of the processes, but we will discover that later, I think. Yeah, here he's in node 1 localhost, and he spawns and the node 2 localhost makes a puts with the node name, and it will output this. Okay, but in the current EX instance, right? Target node, okay. Runs on the, okay, that runs there, but I will not get the feedback there, okay. Ignore the chicken sounds, okay. Let me see. I already connected, no dot spawn. How can I see all the process? I don't know, but I will find it. I don't want that music. Neither that one. Yes, this is a good one. Yes. Goodbye. Okay, the name is right? It's techno localhost. Okay, I believe. I just want to believe. Okay. Here. I send it to hyperlocalhost. Hyperlocalhost. Okay, it's everything right. So I just believe that it ran in the another node. Oh, the live is over. Thank you for watching. I don't know who you are. I have two people watching right now. One of them maybe is I don't know who you are, but thank you for your audience and for showing up. And tomorrow I will do the same. Okay, and until tomorrow. This is a good music. Listen to it.